Welcome to the course of compiler design. In the previous session, we discussed the evaluation of S attributed and L attributed definitions. Today, we are going to see some of the example of evaluation of SDT. So you all know there are two types of SDD, that is S attributed definition and L attributed definition. In the case of S attribute definition, it contains only synthesis attribute. In the case of L attribute definition, it contains both synthesized and inherited attributes. The translation schemes specify the order in which the particular semantic actions are performed in a SDT. Based on the evaluation, we can group it into topological sort or top-down parser, bottom-up parser techniques. In L attributed definition, we use topological sort, that is in order. In the top-down parsing, we are using leftmost derivation. In the bottom-up parsing, we are using rightmost derivation. It is mainly used for S attributed definition. S attributed definition, that is the case. Then today we are going to see some of the examples of these SDTs. That is, first we are going to see one example, that is EL produces E small n, then E produces E1 plus T, then E produces T, and T produces T1 star F, and F T produces F, and F produces opening bracket E closing bracket. Then F produces digit. You can also see the semantic rules associated with this production. Here there are two attributes, that is val and lex value, that is lex value. So we are going to test which type of attributes these are. The first the val is a in concern about val, it is a synthesis attribute. You can see that in the semantic rules, the val value of L is evaluated from its child node, that is L dot val equal to E dot val, and E dot val equal to E1 dot val plus T dot val, then E dot val equal to T dot val, then T dot val equal to T1 dot val into F dot val. T dot val equal to F dot val, and F dot val equal to E dot val. In all the cases, you can see that the value of a non-terminal is evaluated from its child node. So the val attribute is synthesis attribute. In the case of lex value, it is a lex value means lexical value. The lexical value is produced or categorized by the first phase of the compiler, that is lexical analyzer. That may be a constant, that may be some attribute, something like that. We can say that it is one of the attribute. Here it is we are mentioning as a digit. So both the attributes are the synthesis attribute. So we can say that it is a S attribute definition. Okay, this is a S attribute definition, or we can say that it is also an L attribute definitions, because all the S attribute definitions are L attributed definitions. Okay, so the evaluation of this particular example, we can do it in both the ways, that we can consider it as a S attributed definition, or it can be considered as a L attributed definition. If we first consider it as a S attributed or L attributed, this is an example for this particular production, or this SDT is an example of desk calculator. It is used to evaluate some of the expressions in the mathematics. So to perform this evaluation, we are associating some number to the semantic rules. That is, you can see that the semantic rules are numbered from 1 to 7. Then to find our aim is to find the L dot value for the expression 2 plus 3 star opening bracket 4 plus 5 the closing bracket. So This is one of the example for desk calculator, and we are going to find out the value for the expression opening bracket 2 plus 3 star, and then opening bracket 4 plus 5 star 5 closing bracket. Okay. In the case, if we consider to evaluate the particular expression, we are going to create the parse tree for the string. Our parse tree will be like this. You can see in the screen. This parse tree will be correspond to opening bracket 2 plus then 3 closing bracket and plus star opening bracket plus this is for the expression, that is opening bracket 2 plus 3 then closing bracket star opening bracket 4 plus 5 closing bracket. This is the parse tree. You already know how to draw the parse tree for a particular input string. Then to evaluate this, we can associate the semantic rules to the parse tree, so it become annotated parse tree. Here we numbered the each and every rules by 1 2 3 up to 7. So we are associating this information to the parse tree, then it become the annotated parse tree. Here you can see some numbers on the non-terminals in the or nodes in the parse tree, so it become annotated parse tree. Then the evaluation, come to the evaluation, we can perform the evaluation in both the case, because the given SDT is both S attributed and L attributed definition, so we can perform the S attributed evaluation also and L attributed evaluation also. In the case of L attributed definition, we are following the topological sort. That means we are performing the in-order traversal. It may be easy if the particular grammar is L attributed. We can follow the in-order traversal, or we can say that it is a topological sort, or we can say that it is a depth first traversal. That is, we perform the leftmost element in the parse tree, then going to the right. Also it is in the order of depth, from depth to up. Then that is the case. Here you can see the first value will be evaluated in order. It will be the digit lex value will be assigned to f, that is 2 will be assigned to f, then that value will be assigned to t, then that value will be given to e. The next will be evaluated is then the right side of this that particular subtree, that is the digit 3 will be given to t value. Then that value will be evaluated as 5, then that 5 value is given to f also. Then that 5 is given to t value, then it is going to the right subtree, that is in the right subtree, the first the in order will be, that is digit dot lex value will be given to f dot value, then f dot value will be given t dot value, then that value will be assigned to 4. You can see that the 4 the value, the lexical value 4 will be given to assigned to the e dot value. Then the digit value 5 will be given to the f dot value, then that 5 will be given to the t dot value. Then the value of e will become 9 on the parse tree. That is 4 plus 5, it is 9 in the parse tree. Then that value will be assigned to f dot value. Then we will evaluate the value of t dot value based on the t dot value star f dot value. Then 5 into 9, that will become 45. That value will be given to the upper node, that is e dot value. The e dot value will become 45. Finally the value of L dot value will become 45. Here n stands for, it is used for a null line. That is it can be also performed by using the S attributed definition evaluation also. For S attributed definition, we are following the rightmost derivation in reverse order. Here you can see the rightmost derivation. That means we are we are expanding the rightmost non-terminal in this particular derivation. We start from the start symbol L. We want to get a expression opening bracket 2 plus 3 star opening bracket 4 5 closing bracket. So for that we are going to start from the start symbol L. Then the first derivation is L produces E n. Then the value of E is the expanded by the production E produces T. Then the value of T is expanded by the production T star F. So then you will get the corresponding in the each and every expression in the each and every steps in the derivation. We are following the rightmost derivation, that is rightmost element is replaced here in each and every steps. Then the reverse of this is used to find the for the evaluation. So we will start from the last rightmost derivation, that is we get the string as opening bracket 2 plus 3 star or closing bracket star opening bracket 4 plus 5 closing bracket. Then we will go to the reverse order. That is why the bottom of parser or a star attribute definition following rightmost derivation in reverse order. So first you will start from the last derivation to the first derivation in the reverse order. That will be, so that value of 2 will be assigned to digit and the digit value is assigned to F. Then F is become T, then T will become E. Then like that we are going to perform the reduction. On the same way you will get the parse tree as you can evaluate the same expression by using the parse tree in the we discussed in the previous section also. Then come to the second example. Here is a productions, that is B produces TL, then T produces int, and T produces real, and L produces L1 comma ID, and L is equal to ID. Here you can see also some semantic rules associated with these productions. First there are two attributes, that is first one is in and second one is type. The type and we are going to identify which type these attributes are. The value of in the first, the semantic rule in the first production is L dot in equal to T dot type. So the in is evaluated, that is L dot in is evaluated from its left sibling. That is, you can see the production D produces TL, the T is the left sibling of L. So the value of L is evaluated from the left child. So L dot in equal to T dot type. So it is in is a inherited attribute because its value is evaluated from its left sibling. Then you can see that the T dot type equal to int. Then the second production T dot type, that is the value of the T is evaluated from its children. So type is a synthesis attribute, and also in the type is evaluated, type of is equal to real. In the case of L produces L1 comma ID, the value of L1 is evaluated from its parent L, that is L1 dot in equal to L1 dot in. L1 dot in equal to L dot in. So value of L1 is evaluated from its parent node. So we can say that the in attribute is a inherited attribute. Then there is one function that add type, which add an entry to the symbol table. That is we are storing all the details of each and every tokens in the symbol table. Whenever you find an identifier, its corresponding value is value or type is entered, or in all informations are stored in the table symbol table. So for that we are using the type functions. If you find an identifier and in the next production L produces ID, the id value is the id value is added into the this symbol table. Consider an example that is real id1 comma id2 then id3. This is a normal definitions for in the C language. Before we are going to use a particular variable, we are defined in the program like real comma id real space id1 comma id2 id3 like that. To evaluate this particular string, we are going to construct the parse tree for the string. That is from the production we can see that it is evaluated by using the parse tree. D produces t type equal to real, then like that. Here you can see the evaluation of the parse tree. So it will be, if it contains both synthesis and inherited attribute, it can be performed only the evaluation of leftmost derivation. That is, it is a L attribute definition, so we can perform only the we can topological sort. We can perform only the topological sort, or we can say that it is we can perform in-order in this particular evaluation. So the first the type of real is evaluated, then the right part of this in-order traversal will give the corresponding. This particular grammar, that is this grammar is mainly used as a symbol type checker. That is, if we define particular variable, we are going to check the type. That is type. It is mainly used for type checking. Then come to the next example. Consider the following syntax-directed translation scheme with the non-terminals S and A and the terminal A and B. Using the above SDT, the output printed by the bottom-up parser for the input AAE is. There is one question that is asked in some on get exam. That is here you can see that here we are attaching not the semantic rules, we are attaching some actions. You can see that there is in the braces the print 1, print 2, print 3, these all are actions, that not semantic rules. Based on the we are not evaluating the attributes values here, so we can say that it is only the actions in print statement. So print or anything, if we are not evaluating any attributes, then we can say that it is comes under the categories actions. So it is an action. In the evaluation of action can be performed by the leftmost derivation. That is, but here in the question it is saying that by a bottom-up parser, what is the value printed by this printed for the string AAB. That is the case. If nothing is mentioned in the question, then we can follow the leftmost derivation, but it is mentioning in this question that it is by a bottom-up parser. So in the bottom-up parser, we are following rightmost derivation in reverse. So we will first construct the parse tree and we will perform the rightmost derivation in reverse to evaluate bottom-up parser for something in some strings in bottom-up parser. So we will create the parse tree for the string. You can see on the right side of this screen. Also, the first we will evaluate perform the rightmost derivation. That is, the rightmost non-terminal is replaced by some other production. So we start from S. Then we want to derive the string AAB. For that, we will replace S by A capital A. That is a non-terminal. On that time, we have to print the semantic. We have to perform the action also. That action is print 1. Then then the second step of the derivation, we replace A by the non-terminal SB. S is the non-terminal, then by using the second production, on that by using the third production, that time it will print the value 3. Then we will replace the rightmost non-terminal S by the small a. So like by using the production S produces a, that is a second production, so we will print the corresponding semantic action, that is print 2. So the rightmost derivation will be 1 and then 3 then 2. So reverse of that will be printed by 2 3 1. That is the case. That is the if we perform this by using the bottom up parser. The same example is we are considered for the top down parser also. In the case of top down parser, we can follow the leftmost derivation. In that is it is for leftmost derivation, we are following the top down parser, we are following leftmost derivation. Hence the leftmost derivation of this string is, that is S produces a, then a is replaced by S, then S is replaced by a. Here only one non-terminal in each and every production, so the rightmost and the leftmost derivation will be same in this particular example. So it will print in the order of leftmost derivation. So it will print first 1, then 3, then 2. That will be printed by in the leftmost derivation. If the same question, it is nothing is specified here. That is same question using the above SDT, the output printed for the input AAB. Here nothing is specified like that. It is following by a bottom up parser or top down parser. So you can simply go to the topological sort. In that case it is following the in-order traversal. That is if it is mentioning like that it is L attributed, then you should go to the in-order. If it is mentioned that S attributed definition, it is you should go to the reverse of RMD. If it is nothing is specified in that, you can go for the leftmost derivation. So the in-order traversal of this will be printed the 1 2 and 3. Okay, thank you.